Let's forget about firms for a minute and just try to understand our prisoner's dilemma game. All right, so the classic prisoner's dilemma problem is that you've got two criminals, right? We'll call them Bonnie and Clyde here, and the police have arrested them for some minor charge, so say possession of a firearm. But the police really think that they committed a larger crime. They don't have enough evidence to prosecute them for the larger crime. And so they've arrested them on a smaller charge, and they're now questioning them to try to get them to admit to the larger crime. In this problem, I have your outcomes laid out here. Of course, the police are going to separate them into two different rooms for questioning. So Bonnie and Clyde don't know what their accomplice is going to tell the police when they have to make their decision. And that's kind of a key part of this problem. Each person makes their decision independently, not knowing what the other player is going to do. The payoffs here are, if they both remain silent, so they don't confess to any crime, the police really only have enough evidence to charge them with the possession of a firearm, the illegal possession of a firearm crime, and they'll each go to jail for 1 year. But if someone confesses to the crime, then Bonnie says, yeah, you know what? We did it, or Clyde did it, and he was the leader, and I just kind of went along with him. Then that person gets to go free. They get this, reduction in their sentence for cooperating with the police, but their partner, Clyde, in this example, would go to jail for the big crime, right? For the robbery, perhaps for 20 years. If they both end up confessing and saying, yeah, the other guy did it, then they're both going to end up going to jail. They'll get a discount on their sentence for cooperating with the police. And they'll both end up in jail for 8 years. All right, so what we're going to do is we're going to take all of this information and we're going to write it into a game matrix, which sounds really cool, but it's really just a table that describes all of the relevant information for a game theory problem. So we've got each player on one side. So we've got Clyde, and Clyde has these choices here. Clyde can stay silent, or he can confess, depending on what row we're in the table. And Bonnie's columns, Bonnie can stay silent, or Bonnie can confess, right? So we've got our players, we've got our strategies, and now we need to fill in the payoffs. So each cell in this table represents one particular outcome. So here in this cell, Bonnie is staying silent and Clyde is staying silent. So we can fill in that if they both stay silent, Bonnie is going to go to prison for 1 year and Clyde is going to go to prison for 1 year. All right, so what's happening in this cell? In this cell, Bonnie confesses and Clyde stays silent. So if Bonnie confesses and Clyde stays silent, Bonnie goes to prison for 0 years. Clyde goes to prison for, that's 20 years. And likewise, this cell down here is where Bonnie stays silent and Clyde confesses, so we have the opposite outcome. Here, Clyde goes to prison for 0 years because he's ratted out his partner. Bonnie goes to prison for 20 years. And the final cell over here is where they both confess, so they'll both end up in prison for 8 years. All right, so we've set up our game matrix, and this is actually not something that I'm going to ask you to do or really even solve a game matrix, because we just don't have enough time to practice all of the oligopoly, game theory topics. But I want to show you how we would work through this problem so that you can understand how firms in oligopolies behave. So how do we figure out now what Bonnie and Clyde are going to do in this situation? Well, basically, Bonnie and Clyde have an option to either stay silent or confess. And when they're making this choice, they have no idea what their partner is going to do. So what we do, the way we approach this problem is to think about all of the possible states of the world, all the possible alternatives. So Clyde does not know what Bonnie is going to do, but he knows that if Bonnie stays silent, okay, if Bonnie stays silent, what is Clyde's best option? Clyde's best option is to go to prison for 0 years. It's better than 1 year. And so he should confess. Okay. So I'm going to highlight the best options here. So Clyde should confess if Bonnie stays silent. What about if Bonnie confesses? If Bonnie confesses, again, Clyde gets a lower prison sentence if he also confesses. So again, we'll highlight that 8 years is better than 20 years. All right, so no matter what Bonnie does, Clyde is always better off confessing, and we call that a dominant strategy. A dominant strategy is when one strategy, in this case confess, is the optimal strategy, the best strategy, regardless of what the other player chooses to do, right? So there's no ambiguity in this situation. Clyde is always better off confessing no matter what Bonnie decides to do. Okay. Bonnie doesn't know what Clyde is going to do. But she can evaluate her best outcome either way. All right, so we want to start to think about this problem from Bonnie's point of view, and it's actually what we call a symmetrical game, meaning that Bonnie's choice is exactly the same as Clyde's choice, so you probably already know what she's going to do. But here, Bonnie has this choice between silent and confess, and she doesn't know whether Clyde is going to stay silent or confess, but she knows if Clyde stays silent, she has a choice between these two outcomes. 1 year, oh, I'm sorry, my internet is really slow right now apparently, and 0 years. So 0 is better than 1. So Bonnie will choose to confess if Clyde stays silent. If Clyde confesses, she has a choice between 20 years and 8 years, and again, her dominant strategy here is to confess. If it's the best option for her, regardless of whether Clyde stays silent or confesses. So both players in this game have a dominant strategy of confess. Which is sometimes referred to as defect or cheat in the context of prisoner's dilemma, but in this case, we've defined it as confess. Okay, which means that our Nash equilibrium in this case is going to be where both players confess. Now, in game theory, we define equilibrium a little bit differently than we do in other types of models. So an equilibrium here is where, given what the other player does, like holding constant what the other person is doing, you cannot do any better than, in this case, confessing, than doing what you're doing, right? So you are taking the best option given what everyone else is doing. And it is actually possible for some different game theory models to have multiple Nash equilibria or to have no Nash equilibrium. So this is a little bit of a different concept than what we've talked about before, but in this case, the Nash equilibrium is where both people confess. Okay. And that presents us with a dilemma, right? So it's called prisoner's dilemma because there's really like a contradiction of interest here. In this game, the incentives are structured in such a way that both people will end up confessing. Of course, the police have structured the incentives, so that's what's best for the police. That's the reason why the incentives are set up this way. So they've given both people this incentive to confess. Likely both people will end up confessing. But the dilemma is that they both would be better off if they stayed silent, right? Confess means that they're going to go to jail for 8 years. If they had both just stayed silent, they would only go to jail for 1 year. So the dilemma here is that the players, in this case, Bonnie and Clyde, end up in jail for 8 years, but would have only served 1 year if they had stayed, sorry guys, silent. All right, good. So that's a prisoner's dilemma problem. We're going to apply that to Oligopoly. But before you do, if you would like to see prisoner's dilemma play out in real life, there was actually a game show called Golden Balls in the UK, and they basically, at the end of the game, the two players played a prisoner's dilemma game against each other. So if you'd like to take a look at that, I've posted a video in the lecture materials section for that. And then in the next lecture video, I will be applying this prisoner's dilemma problem to firm behavior in Oligopoly.